Welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. Today we're talking about a possible Sunspot 2882. Will it be on the solar disk facing the Earth long enough to be named? Well, it's something to be discovered, TBD. Also looking at jet stream extremes, hydrogen phases, and a CME forecast. Yes, we forecast CMEs. So here's Sunspot 2881. Not 2881. Sunspot 2801, which is this one right here. But we spontaneously saw one form right here. It's pretty close to setting. It may not be on the sun long enough to get a name, but we did see some umbra appear there, and so there's your report on it. Here's another view of the local yellow dwarf in 171 angstroms and colorized magnetogram. It's a one-day SDO browse data set of images. And let's take a look at Lagrange point 5 since I just said coronal mass ejection forecast. Lagrange point 5, the location of stereo A. So here you can see what's going on from the viewpoint of Lagrange point 5. And this large plasma plume right here is very likely to eject at some point soon. So don't be surprised to see another video coming out soon highlighting the upcoming coronal mass ejection, the likely coming coronal mass ejection. Here's where stuff is located in the solar system. If you're wondering where Lagrange point 5 is, it's someplace around here. And Lagrange point 4, where stereo B is someplace around here. There's where stuff will be in 1 week. Will be 1 day from a new moon. And here's a star chart. This is what's going on above my head in Lehigh Valley, Pennsylvania. The moon is out there, and the skies are not clear as it continues to snow. We were at the epicenter of the blizzard here in Lehigh Valley, Pennsylvania. The 10.7 centimeter radio flux, which is the radio flux output of the solar outer corona, currently at 73. Way down there. And if this was actually filled in here on the Space Weather Enthusiast dashboard, it would be way down here. Below 75, obviously. Anyway, there's the radio flux through the... Oops, that was a sunspot number. My bad. Oh, no. Okay, there we go. So there's a sunspot number progression. Cycle 24 and the beginning of cycle 25. And there's the radio flux progression for cycle 24 and the beginning at cycle 25. We've got some splentacular helioviewer movies to show you today. Allow me to vanish and check the life of the stream before we start showing you some great footage from helioviewer.org. First, the 193 angstroms view. So we're still seeing a increased solar wind speed here, and it's from this coronal hole over here, which is now setting. You can't see it too well. There's also one close to the equator right here, and of course this one here, just moving out of the Earth-facing zone. We can expect a high-speed wind stream from that one, probably an even stronger one, in about 3 days. 2 to 3 days. Here's 304 angstroms. And I don't know what's going on with the Earth scale. You can see the Earth over there on the left in the scale. For some reason, scrawled on the sun. And those plasma filaments we showed you from the perspective of stereo A, they're all up in this area. You can kind of see them pretty well in that image. Also a pretty spectacular prominence there in the northwest ahead of Sunspot 2801. Here's 171 angstroms. You can see the formation of Sunspot 2802, possibly Sunspot 2802. Not sure if it'll be visible long enough to reach the 12-hour mark and get a name. Here's the southern hemisphere in 193 angstroms, a good close-up of that coronal hole. And here's 1700 angstroms. And you can see those umbrae form. That new Sunspot actually does have two umbrae. It is beta class. Again, whether or not it gets named has no bearing on whether or not it produces some solar flares. The likelihood of it producing some solar flares a little bit higher now. Again, it does have two umbrae. It's beta class. Here's 94 angstroms, and we'll save the rest of our close-ups of the northwestern portion of the solar disk for the end of the video, as there's lots of data to go through. And there's a great cosmology segment coming up, talking about phases of hydrogen. Yes, it's kind of important to understand phases of hydrogen. We'll tell you why momentarily. First, volcanoes. White Island on the list because it's been downgraded. So first, Sakurajima has been exploding. It's producing a 5,000-foot ash plume. Raung on East Java, 14,000-foot ash plume there. I think that's an uptick at Raung. Dukono, volcanic ash reported to 5,000 feet of altitude. And there you can see this report on the decline of the temperatures of White Island volcano. So now back to levels from 2018, actually. Aviation color code remains at green. Fuego, sporadic emissions of ash as it mildly explodes in Guatemala. Sangay exploding. Flight level 190, it's a 19,000-foot ash plume. And Sabancaya, 23,000-foot ash plume as it explodes. Please do not attempt to do a handspring over the caldera. Largest earthquake of the past 24 was this 6.7, or perhaps a 6.6, off of the coast of Chile. There's the location of that. And no tsunami warning, advisory, watch, or threat issued from that. I checked all the reports. And that came in just a couple hours before we made the video here. Oh, okay. It came in just before midnight. Oh, no. It came in at 00:23, so 23 minutes after midnight. All right. There we go. I figured it out. Small deep quake over Puerto Rico happened yesterday. Under Puerto Rico, rather. And we'll scroll up the list here. As the earthquake drought continues, a 5.7 struck near Fiji, in the deep quake capital of the world, but that one was at the surface at 10 kilometers estimated depth. Here's a deep one near Tonga at over 530 kilometers depth and a 4.5 magnitude. Again, there's that 6.7. That was the largest of the past 24. And the 7, 8, and 9 magnitude earthquake drought continues, folks. If you're in an earthquake-prone zone, especially areas like these, have an earthquake plan. Attempt to be an asset, not a liability, in the event of a disaster. If you're wondering who the cavalry is, you're probably the cavalry. Have you checked out our new merch at the Redbubble shop? You can link to it all at smAshomash.com. Have a look if you're in the market for some merch. It's pretty edgy. Visit our own website. You can find us on social media all over the place. And the links are all there on the homepage. That's the smAsho merch. Also check out our forum. There's a cosmology, earth, geophysics, heliophysics, a free-for-all forum, and it's all currently free-for-all. There is no paywall yet at smashomash.com. And welcome to all you viewers to the Neo Renaissance. Now this Smash stream is being streamed live to Twitch. Perhaps download their free mobile app. It's twitch.tv/smashomash is the URL for our Twitch page. The Twitch mobile streaming platform is fantastic. Thanks to our followers over at Twitch. And if you're watching on YouTube, please don't forget to press like, subscribe, notify, and share. Thanks to our new viewers at YouTube, youtube.com/smashomash. Check out our playlists. You'll find all kinds of information that you may not otherwise know. Some Blizzard videos. And remember, if it's brutally cold and snowing and blowing where you are, keep your bird feeders full if possible. Birds use lots of energy. When it's very cold, again, youtube.com/smashomash. And once again, the video cannot continue, and the place will continue to burn until you press like and subscribe. Also, leave a comment if you've already done so. While we wait for everybody else to press like and subscribe, you can pause the video. We'll be here when you get back. Press share. Share on your social media. Tell your friends, your foes, your science noobs, and your science pros about the channel and about the Smash News Network, least busted name in news. If you do not press like, subscribe, notify, and share, you may suffer from crippling body odor, as our marquee at the bottom of the screen is indicating. Thanks to our BitChute subscribers, we've now reached 350 subscribers over at BitChute. Cheers, there is some exclusive content there. If you're only watching on YouTube or on Twitch, make sure you watch us in the other spots because we are putting exclusive content on all of our social media sites, all of our video hosting platforms, etc. And allow me to put this fire out before the cosmology segment. It could hurt the aesthetics. So today we're going to look up a random object, but first we're going to thank our patrons. Thanks, patrons, the true source of funding for the content. Our Patreon credit crawl will be updated shortly. Thanks to our new patrons, old patrons, medium-aged patrons, etc. Patreon.com/smashomash is the true source of funding for the content. We make just this side of nothing on the YouTube videos. Why? I have no idea. Should I blame a shadow ban? I don't know. I'm not going to say anything about it, except our subscriptions are stagnating. Here's a random number between 1 and 1031, which coincides with the number of objects tracked over at the Neil Gorell Swift-Bat X-ray Observatory, and today's quantum number is 20. So right near the top of the list, let's see what this X-ray transient might be. It's XTE J0055-727, a high-mass X-ray binary, which is always interesting, and the alternate name is Macho 208.15911.13. Here are the X-ray transients from that object, the high-mass X-ray binary. And there you can see the historic chart going back about 15 years. Pretty consistent X-ray source, historically speaking. And let's take a look at this one on Simbad. See if we can see it on. So it's at a very densely populated part of the galaxy, I would assume. There it is on Aladdin Light. And let's take a look at it in some other wavelengths here, see if we can get some better images. So a great image of it there on Chandra, the high-mass X-ray binary. Typically two stars of differing mass, one siphoning plasma off of the other one. Here it is in infrared, not very bright in that. How about the Spitzer? A little brighter on the Spitzer. How about an optical? There we go. Again, a very densely populated portion of the galaxy, most likely. It's probably close to the galactic disk. Let's zoom out on the 2-mass and see if we can see where it is. Oh, nowhere near the galactic disk. just a densely populated portion of space. And there it is on XMM Newton, the multi-mirror project. Again, this high-mass X-ray binary is called XTEJ0055-727, a super catchy name. It's an X-ray transient. Now let's talk about phases of hydrogen. Why? Because it's very likely that the sun is made out of condensed matter. What kind of condensed matter, you ask? Liquid metallic hydrogen, and probably solid metallic hydrogen. Now, solid metallic hydrogen has never been created in a lab. What you're looking at here is the x-axis is the density, and the y-axis is the temperature. So, what happens to hydrogen under these very high densities? It turns into a metallic fluid and then a metallic solid, depending on temperature. And it all has to do with valence. When you press the atoms close enough together, their electron sharing comes into play. And I'm going to play a little clip from this. This is from Sky Scholar channel. Make sure you follow Sky Scholar, Dr. Robitaille. Here's a small clip from the video.
Ever produced by the astronomers for such a claim. Their evidence is purely theoretical and dates back to the 1860s when men like F.B. Faye first tried to argue that the photosphere was just an imaginary layer.
So make sure you watch that video, subscribe to all the content. Watch all the videos over there at Sky Scholar. And the sun does exhibit solid body rotation. So a plausible explanation for it is that it's made of solid metallic hydrogen. The photosphere, liquid metallic hydrogen, it all makes a lot more sense and is a lot more plausible than a gaseous plasma star. So the implications to the rest of cosmology are vast, and the entire branch of science needs a rewrite. Robitaille is on top of it. So check out the Sky Scholar channel. He's only got 29,700 subscribers. He doesn't need our help. Perhaps we need his. And that's today's cosmology segment. Let's get back to more data. We don't see any X-ray flares happening. There's the GOES X-ray flux over the past 3 days, as measured by the GOES 16. And we don't see any proton strikes either. No coronal mass ejections have been striking the magnetosphere lately. We'll let you know if they do. It's part of the reason why we have a channel. And here's the real-time solar wind. We still see an increased solar wind speed here. Solar wind speed still at 532 kilometers per second. Solar wind density just under 7 protons per cubic centimeter. As the coronal hole wind stream continues, the KP index now has come down to 2, having reached geomagnetic unrest conditions a few times for about 9 hours and then again for about 3 hours yesterday, February 2nd. Here's a geospace magnetosphere movie showing magnetohydrodynamic pressure. And that is from that high-speed solar wind. It's 4 hours of data. Let's allow that to refresh. And fairly steady there over the past 4 hours. Here are ground magnetic perturbations. You're looking at geospace delta B, which would be changes in the Earth's B field. And we show both of these daily as the archival data is not viewable. And of course, since we are living through a geomagnetic excursion, and maybe we should make a video just about that sometime. Here is the 30-minute auroral forecast. And we should see some slightly increased auroral activity as a result of that high-speed wind stream. And there are some great auroral photos at spaceweather.com. If you haven't checked that out, spaceweather.com. Always with the great auroral galleries. Calming down a little bit there. Again, KP now at 2, and the KP index is a measurement of global geomagnetism. Here's the 3-day chart for the GOES magnetometer, and we see some pretty spiky data here. This is the Earth crossing into the North Pole oriented current sheet, and we may be in the process of soon going back into the South Pole, into a South Pole current sheet. We'll show you the graphics on that right after this. That's the 3-day GOES magnetometer chart, and those arc jet moments are the GOES 16 using its thrusters to maintain its position. Here is the top view ecliptic plane field plot, and you can see the Earth is currently in a North Pole current sheet shown there in green. Here's the last image. And I would expect to see continued spiky readings and pretty high readings on the GOES 16 magnetometer. Man, that is some really old data. Over 9 hours old. We could already be in the South Pole current sheet. I wouldn't be surprised. That data is exceedingly old. Here's a line of sight field plot. I won't spend too much time on these because the data is so old. And there's the coronal hole field plot. It shows you the sun's B field in blue. No major changes in the B field. Next, we're looking at the coronal magnetic field plot. It shows you open potential field surface source lines in purple or black, depending on if they're coronal holes or polar coronal holes. And it shows you closed potential field surface source lines in pink. The sun's atmosphere, known as the corona, is a chaotic place. We show this daily also on the daily space weather videos. Here's a diagram of the atmosphere, and that GOES 16 satellite makes its measurements at that red F there, just over 300 kilometers of altitude. This diagram here also shows you penetration of electromagnetic radiation into the atmosphere. And here's another diagram showing you the altitudes of the Van Allen belts, GPS satellites, a low Earth orbit, Van Allen probes, etc. And we've seen the charging hazards just calm down a little bit. Since I did show prep, there were more of them when I did show prep. Now there are less minor charging hazards there over Central America and Mexico, north of the equator. Here's the GOES electron flux, a measurement of electron density. We're counting how many electrons essentially are at the F ionosphere layer. And you can see pretty low levels here. Pretty much in line with the forecast. Nothing to write home about there. There's the 1-year chart to put that into a historical context. And here's the total electron content forecast. This is a visualization. And we're seeing some anomalies here. You can see electron charge-ups at nighttime. A feature more common when we see low levels of electron flux as it gets a little bit more disorganized. I'll let it play through a second time here. And there's the forecast. I would tend to agree with the forecast. This part, at least. I would agree with that. But I think it's going to go back up again on the 5th. Because the coronal hole wind stream will have subsided and there will be electrons out there as a result. Or perhaps as a contributing factor. Here's the map of the ionosphere. And the ionosphere is looking pretty normal here. A little bit on the charged up side, both day and night. Not too anomalous, though. There's the current image at 9:30 Universal Time. And here's the jet stream chaos that we were talking about in the title. Check out the area west of Australia. East of Australia. This area right here. Talk about chaotic jet stream flow. It's summer in the southern hemisphere, and their jet stream is all over the place. Check it out. South Pacific. Some funky S-shaped jet stream activity going on out there. Here are the jets of the Western world. And you can see a doubled up jet stream over the Atlantic Ocean, a massive divergence over the Pacific Ocean. And you can see some jet stream blowing backwards there off the west coast of Mexico. The extreme meridional jet stream flow that we see here looks just like the diagram of meridional jet stream flow, as opposed to zonal jet stream flow, which is a little bit more smooth looking. And check out the chaos in the north geographic polar region. Jet streams are all over the place. For more meteorological data, let's look at the U.S. Doppler radar map as it continues to snow and snow and snow. It looks like some heavy bands even striking us here in Pennsylvania. It's been snowing for, I lost track of how many days, as a low stagnated off the coast of New Jersey and is now finally moving up to New England. We'll show you in a minute. There you go. That low is now off the coast of Maine. So there's where things are now. We'll advance this in the GFS forecast until tomorrow at about 1 p.m. There's where we expect pressure to be at 1 p.m. That low losing a little bit of coherence and moving north. High pressure off the coast of Oregon. And high pressure largely dominating the Pacific Ocean. Let's continue on. Here's the cloud layer over the U.S. Let me blow that up. There we go. And you can see this large-scale counterclockwise rotation here, a feature of low-pressure systems in the northern hemisphere. Some rapid cloud nucleation here north of Cuba, and a bunch of low clouds continue over the Atlantic Ocean. Quite a few over the Gulf of Mexico as well. You can see those characteristic low clouds there. Here's the water vapor map, and there's the cloud layer again. And if you're confused about what your Doppler radar is showing you, head to the NASA GOES Interactive Weather Satellite Suite and do a zoom in on your water vapor situation. It'll give you insight into the way the water is moving. And keep in mind, new viewers, this is high pressure. These dry regions contain more massive air. Dry air more massive than moist air. Part of the reason why dry air is associated with high pressure and moist air is associated with low pressure. Once again, there's the cloud layer. And there's the water vapor map. So thanks, SMASH team, for tuning in. Remember, we don't promote fraud on the channel. Perhaps pick up some merch and promote us on the channel. Here at the SMASH News Network, we are the least busted name in news. And we noticed a void, and so we filled it. And we didn't fill it with fraud. Are you accountable? Again, please press like and subscribe on YouTube. Thanks again to our YouTube viewers. Please share the content on your social media. Tell your science noobs, science pros, your friends and your foes. We've got bonus features. We're going to show you a close-up of that new Sunspot. And here is the intensity gram. I doubt it's going to get a name. I doubt it'll be Sunspot 2802. It's about to set, so you can see that sunspot right there near my pointer. There's Sunspot 2801. Here's the magnetogram of that area. Pretty low levels of solar activity overall. And let's show some close-ups of those two regions of activity. Here is me vanishing. Here's 94 angstroms. Here's 335 angstroms. Here's 193. And check out the filamentary behavior up here. And you can see some of those filaments looking like they ejected, but they actually stayed in the corona. So again, the likelihood of a coronal mass ejection, quite high. The likelihood of an Earth-facing coronal mass ejection, not as high. Anyway, there's 193. And last but not least, we've got 171 angstroms. It's about time to close this thing out and get it uploaded. Thanks again for tuning in, folks. Remember, stare at the sun. Attempt to understand the physics. Don't drink. And if you do drink, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. May that solar wind be at your back.